So today we're going to be looking at influence line, sample calculation on influence line. And let's take this example. For instance, we are asked to draw the influence line for the vertical reactions at support A and support E, and also the reaction moment at support E of the beam, also the shear and bending moment at point B and D. Now let's say, for instance, we have a hinge at point C here. So the first thing is we're going to resolve and get our reaction AY and EY, then before we can proceed with our calculation. So to get this, let's take segment A to C, summing moment about position A to be equals to 0. So because this one is hinged, that's why we are taking this segment. Assuming it's not hinged, we have to take the full length from here to this particular point. So for this particular one, we take the moment about this point where this is the only force that is coming to this point there. We have 1 times x minus cy times 8. Now the sign convention we're using is that clockwise is positive while anti-clockwise is negative, so that's why this one is negative. So at the end of the day, we have that our cy will be equals to x over 8. Now let's taking that into consideration, we move to the second point, which is introducing our point load at this point, and also looking at this other side. When we do this, we want to take moment about point E. Now taking moment about point E, as I explained the other time, we are going to neglect the other side of the hinge. So if I take moment about this point E now, if you look at this side, there's no force along this side, only this particular force. So summation of moment about point E, we have this moment minus, because this one is coming clockwise, that's why it's plus here, so minus this one coming to this place because we're taking moment to this particular point. Me times, sorry, cy minus cy times 8, the distance from here to here is 8, equals to 0. Mind you, there's something I was expecting people to ask me, that is why are we, because this is not a force, why are we putting it? Because it's a moment, we cannot neglect it, even though we are taking moment about this point. Because there's a moment acting here, we can't neglect it. That's why we are introducing the moment here. And after getting that from here, since we calculated the other time that our cy is s over 8, so we put x over 8 here, that means we will have x here, so our me minus s will give us me will be equals to x. Now let us sum to get our ey, this force ey. We have to sum forces along the vertical component to be equals to 0. That is, summation of forces along y axis to be equals to 0. So since this one is coming down, we say minus cy, because our sign convention says anything going up is positive while anything coming down is negative. So since this one is coming down, we have minus cy plus ey to be equals to 0. So from here we can deduce that our ey is equals to cy, and since cy the other time equals to s over 8, definitely our ey is equals to x over 8. Proceeding to the next one, this time around we are taking the want to consider segment C to E, and this time around we are considering the distance of 8 is less than or equals to s, which is less than or equals to 16, that is considering this side. So I will say consider this side, then we look at this side in the calculation. So looking at this, we have, I want to consider segment CE, and 8 is less than or equals to 16, s which is less than or equals to 16, that is from this portion to this portion. So what we take into consideration is we want to look at some moments about point E to be equals to 0. To do that, since we are taking moment about this point, we are considering this moment also. We consider cy, and but this time around, since the point load is acting here as against the other time that is acting here, so sorry, I think I've I've lost count. Okay, so since we're taking moments about this point, and I told you that this moment we have to consider it, and as I explained the other time, that even though the load is acting here now, we are putting the point and the unit load here. Now let us take moment about this point and see what we are having. The only forces that we have at this segment is this one and also this CY pointing downward. So if you are taking moment, we have moment about E. This one is coming clockwise and this one is coming counterclockwise. That's why we have minus CY, and it's going to travel a distance of 8 meters before getting to this point. That's why we have minus CY times 8. Now we also when we proceed, there's a unit load here that we're considering. This is the one we are considering, and considering this distance, since we are considering from A to S to 16, that is from this segment, that is our unit load can be any distance here. Definitely what we're saying is that this distance S is going to be something like this 16 minus X, because the whole of this distance is 16, so this span is 16 minus S. So if this X, whatever the S is, the distance traveled is going to be 16 minus X. So even if this one is 8, it will be 16 minus 8. If this is 10, it will be 16 minus 10. So with regards to S, we are saying 1 times 16 minus S equals to 0. Now if we adopt the same sign convention that we did the other time, taking summation of forces along the vertical component to be equals to 0, the only one we have is we have this one, we have this one, and we have this one. So to do that one, this one is coming downward, which is negative CY. This one is coming downward, which is negative 1, and this one is coming upward, which is plus 1, plus EY rather. So we have minus CY plus EY minus 1 equals to 0. So if we do that calculation, and even though we know that CY equals to 0 earlier on from our initial understanding, if we put our 0 here, definitely our EY will be equals to 1. So that's where we have this. Wherever you see this condition, I'm trying to say that formally we have calculated whatever we have here. When I put this asterisk, that means we have calculated it before, so that we will have understanding of what we are doing here before the calculation changes. So now if we want to draw the influence line for reaction at A, now what we are going to do now is that we'll look at the our equation at x equals to 0. What is our AY? So from the equation we have AY equals to 0. So definitely when from 0 to x, from 0 to x to 8, that is, we want to consider, let's say when we put our at distance 0 here, what will be our AY? Our AY will be 1. Even though we are considering unit force, AY will be 1. Now when it moves here, it continues to diminish until it gets to, our AY will continue to diminish until it gets to this particular point, when our S would have covered a distance of 8. Because if you remember, the influence line for reaction at A, it's maximum at, let me say it's 1 at point A that we're considering, then it continues to diminish it down. So for at x equals to 8, our AY will be equals to 0. Now if we look at the other side of the segment, that is from 8 to S to 16, now looking at this now, at s equals to 8, what is our AY? Our AY will equal to 0, because our AY is there's an hinge here. That is why our AY is 0. At also at s equals to 16, our AY is equal to 0. Note, if we don't have hinge here, our AY would have continued to be negative and be coming downward like this. So that one is very important. So using this illustration, this is the diagram we have here for the reaction at A. You can see the influence line for reaction at A here. Now let us look at influence line for the reaction at E. When we put our unit load at E, that is from 0 is less than S equals to less than 8, our EY equals to x over 8. We already have that establishment here. Now since we already have this equation, then we will now look at the other side too. From 8 is less than equals to S, which is less than equals to 16. What is our EY? Our EY is 1 here. our EY is 1, as we already have from this establishment here. So we're just trying to write out what we already calculated earlier on, and then we use it for our calculation. So using this illustration, that okay, if EY equals to S over 8 from 0 to 8, then we just put the value of when x equals to 0, what is EY? When we put EY equals to 0 over 8, that means it's 0. When S equals to 8, what is EY? When we put 8 here, 8 over 8, we have 1. That's why we have here. Now, looking at this one, we say our EY equals to 1 from whatever it is. Now, when S equals to 8, our EY is 1. When S equals to 16, our EY is also 1, because there is no changing that something. So, if we draw the influence line based on this relationship, this is what we are going to have here. That is because at EY equals to 0, at S equals to 0, it is 0. At 8, it moves to 1, and at 16, it's also 1. So this is the influence line for the reaction at influence line for reaction at E. Now let us look at influence line for the moment at E. Now, talking about the moment, we have 0 is less than or equals to S, is less than or equals to 8, and we have M equals to S, and likewise this. So all we just need to do is we are going to be substituting this value of S here. At S equals to 0, M equals to 0. At S equals to 8, M equals to 8. And likewise here, EY equals to 1. At S equals to 8, M equals to 8. And at S equals to 16, M is equals to 0. So we use this relationship to draw this particular influence line. So though I'm not supposed to, because I'm supposed to remove, let me just remove this one, since I'm not considering it, I'm only considering the moment. So now, since our moment about E equals to S, so when we have S to be equals to 8, M will be equal to 8. When we have S to be equals to 16, our ME will be equals to 0, because the moment at this point will be 0 at the free end. Now the what's it called? The next one is the shear force, or the influence line for the shear. Now, as we consider also, we are going to do 3 instances. We have to put the unit load at this point, and also at this point. So we are going to consider the shear force from here to here, which is distance of 0 to less than S less than 4. And when we do that, we consider this side of the box. So shear force is not like moment. We just look at the summation of forces along the Y component. So let us look at this at this distance. What is the shear force? If we are summing forces, shear force along Y axis to be equals to 0, that is along the vertical component. Now, I told you the other time that when I'm putting the load here, we consider this segment. So for this instance now, we are putting the load here, so we are bothering about this segment. Now, if we want to take the shear force at this point now, we look at we have this VB pointing upward and this one pointing upward, our EY. So VB plus EY should be equals to 0. So if we do that, since we already calculated our EY in the first instance to be S over 8 in the beginning, so if we put the value of EY there, definitely from here our VB equals to negative of EY. That is what it's trying to say, is that if EY is pointing like this, our VB is supposed to be acting downward to have an equilibrium. So that way we're having minus S over 8. Now the second segment is we're going to put the load here. Now I'll put the load here, and then we consider this other side. So when we put the load here, now what happens at this side? What happens at this left side? Now let's say we are putting the load here, so we consider this side, and looking at it, we are summing forces along the Y axis equals to 0. So that means I have VB and I also have AY. So if, for instance, I say AY and this one is pointing upward, it will be AY plus VB. But this time the way we treated it, the the left hand side is pointing up downward, while the right hand side is pointing upward. That's the way we treated this particular share from the beginning. So since this one is pointing downward, if this one is positive, this one is negative. So if we have ay minus vb equals to 0, okay sir, minus vb plus ay, we can write either of them, minus vb plus ay equals to 0. But our ay, we have calculated our ay to be equals to 8 minus s over 8 from the initial calculation. So as I was saying the other time, since we have I said our ay equals to 8 minus s over 8. Why is this 8 minus s over 8? Since our ay is x over 8, and the summation of ay and ey is supposed to be 1. So if we remove 1 minus this, you give us 8 minus s 8. It should be 8 minus s over 8, that is 1 minus s over 8, something like that. So that's why we have 8 minus s over 8 for clarity. Now let us consider this particular one. We're summing forces along the y-axis to be equals to 0, and from 8 to 16 this side. So mind you, the unit force is acting here. So we have minus vb plus ay to be equals to 0, and our vb equals to ay. But all these forces, they are the other side. They have almost a negligible influence here, which is 0. The shear force at this side is our unit load is here. So our ay and vb, they are 0 at this particular point because of this hinge. The influence is not being felt here, so that we have vb and ay to be equals to 0. Now let us now draw our influence line and consider at different points what our value would be. From 0 to s, which is less than 4. Let's go and look at that. 0 to s less than 4. What is our vb? Vb equals to minus x over 8. So we write it down, minus s over 8. Now using this principle, we're now going to look at, okay, at 0, what is vb? We'll put 0 here, we have 0. We'll put 4 here. What are we going to have? We'll put 4 here. That means 4 over 8, which is 1 over 2. So we have this. Now let us consider at 4 less than or equals to s less than or equals to 8. What do we have at that particular point? 4 is less than s less than 8. We have our ay vb to be equals to ay, which is equal to 8 minus s over 8. So 8 minus s over 8. Now we put the value of 4, and then we substitute our s at different times. If we put 4 here, 8 minus 4 will give us 4, 4 over 8 will give us half. But when our s is 16, 8 minus 16 will give us minus 8 over 8. That's minus 8 all over 8. That's it should be minus 1. vb 8 minus 16, that should be minus 8, then divided by 8. Minus 8 divided by 8, that should be minus 1. So I think this one should be minus 1. Let me check what is happening in this particular point. Oh, sorry, this should be, I'm considering 4 to 8, not, sorry, 4 to 8. So if I put 8 minus 8, that should be 0 over 8. That's my bad. This is the range I'm considering, not the other one. Now let us now consider the third point, from 8 to s to 16. So 8 to s to 16, what do we have? Our vb equals to our ay, and our ay is 0. So vb equals to 0, that means our vb is equal to 0. So from here, when s equals to 8, it will be 0. At s equals to 16, it will also be 0. So using this principle, we're now going to draw our influence line from 0 to 4. What do we have in 0 to 0? We have, it has from 0 to minus half. So 0 to minus half. Now this is 0 to 4. Now at from 4 to 8, we have it to be at 4 we have it to be half. So we protrude it to half, positive side. Then at 8 it comes to 0. It comes to 0 also. But at higher than that, it is 0. That is why we have the shear force diagram to be this way. Now let us go for the moment. Considering the moment, we calculate the moment also at summation of moment at point B to be equals to 0, starting from 0 to s to 4. So we are considering this side when we take when we apply the load here. So summation of moment about B to be equals to 0. So we have moment about B plus moment about E, and we also have our EY coming to this side. Now this one is coming clockwise, which is positive. This one is coming clockwise, which is positive. But this EY to this particular point, because we are taking moment about B, is coming anti-clockwise. So, and it's going to travel a distance of 4 plus 4 plus 4, that's 12. So minus EY times 12. That's why we have this to be equals to 0. So if we solve this relationship, we are going to have our, since our EY is s over 8, our ME is also x, then we have MB to be equals to s over 2 from here, because we are substituting these two values into this particular one here, because s over 8 times 12 will give us 8, 4 here 2, 4 here 3, 3. So yes, at the end of the day, it will give us s over 2 rather. Now let us consider when we move the load to this point. Then when we move the load to this point, we consider the left side. So if we are considering the left side, something moment about P to be equals to 0, we also get our, we already know our EY is equals to 8 minus s over 8 from the initial calculation. So our MB equals to just 4 times this distance, EY times 4 will give us our MB. The MB equals to this times 4, so we have it as this. Or if you take moment about this, you know, this we are considering this side, this first times this perpendicular distance. So we have 8 minus s over 2. The next thing is we consider 8 to s to 16. That is, we put our load here, and then if we are doing that, we now look at the left side. So if we summation of moment about B to be equals to 0, then the moment about B equals to 0 times 4, and because AY will be 0 at this point, because it's outside the outside this, because of the hinge here, so it's 0 in this side. So if it is 0, then this one will be 0. We consider, now we now write out our equation from the 0 to s equals to 4, and moments at that particular point, and from range 4 to 8, and also from range 8 to 6. Now these are the value we have for 0 to 4. We have x over 2. We are going to put that one down, x over 2. Then for range of 4 to 8, we have 8 minus s over 2. 8 minus s over 2, we put it down. Then for 8 to 16, we have it as 0. 8 to 16, 8 to 16, we have it as 0. So what we're going to do is that we're going to be putting each value at s equals to 0, 0 to 4, 0 and 4. What we have, when it's 0, it is 0. When it's 4, it will be 2. Now we have it at 8 minus s over 8, and we consider from 4 to 8, 4 to 8. So at 4, what is the value? If you put 4 here, 8 minus 4, that will be 4 over 8 minus 4 will be 4. 4 over 8. 4 over 8 will give us half. So what am I saying? Let me go 0 to 4 to 8. Let me go and check. 0 to 44 to s to 8. 4 to 8 minus s over 2 over 2. Sorry, over 2. Rather, yeah, over 2. Now, if this is what we have here, if I put 4, what do I have? 8 minus 4 will give me 4 divided by 2. That's 2. Now, if I put 8, here, 8 minus 8 is 0 over 2, it gives us 0. That's what we have here. Now, let us consider from 8 to 16, we have it to be 0. So, when we have 8, 0. When we have 16, it's also 0. So, what we're going to do, we're now going to draw the values of our MB From 0 to 4 is 0 to 2. From 4 to 8 is from 2 to 0. Then from 8 to 16 it is 0. That we have it this way. So this is our moment influence line for the moment at B. So I think that is all on that. Thank you.